that they have here is summarising what's in the diagram, if there's a diagram. Okay? So now they've said the bearing of the ship from P is 062. Now, bearings will normally discuss a from point. It's the from point that you would always draw a north line, and then the bearing is always measured in a clockwise direction. So they're saying that this angle here is 062. Bearings are always given in 3 digits. Okay, so that's why they write it 062, and in fact they've just said that this is 62. Everyone clear on that? The bearing of the ship from Q, so again, here's our north line from Q, our bearing is 036. Calculate the distance QS. So we need to find this measure here. Which topic do you think this is looking at? Triangles. There's a triangle there, so what topic? Now, SOHCAHTOA is for just for right angle triangles. But what other formula? Do you remember I asked you to make sure you had a formula sheet with you this week?
Yeah, it's right here.
What other formula did you get given? 3? Is it? Yeah, the sine and cosine rule. So can you find your original what's it?
Yeah, let's get it.
Alright, so the sine and cosine rule apply to any triangle, not just right angle triangles. They do apply to right angles, but they apply to any triangle. So if we're trying to find this length here, we need to establish what information we've been given. We know this length, that's the 2.9. We know this angle is 36. We're trying to find this length. Now they told us this angle at the top here. Which other angle could I establish from that information? Gabriel?
But it is from the rest is 100.
Do you mean this part here? Yeah. So that there would add up to 180 because it's a straight line. And so what would the green angle there be? 118. Yes, Trismina? So now I've got an angle, the length opposite it. I've got another angle, and I'm trying to find the length opposite that. Which of the rules are we going to use in this case? Sine rule, yes? You all happy with that? Remember, 2 sides, 2 angles is the sine rule. So we say that x over what? 118 equals 2.9. Now, what mode should we make sure our calculators are in before we start? Degrees, day. And we're going to rearrange this bad boy, and we have 2.9 over sine 36 multiplied by sine 118. Do that, chuck it in the calc, round to 368. Now, I'm not going to do that, like I'm not going to finish it off, I'm just going through these things to make sure I help you out. Next question I'm going through is this one. I think it's the next one in the book. I really am trying to do this as quickly as possible. You can finish off and tidy up these later. Okay? I'm just trying to get you thinking about these things. Now, Casey?
Yeah.
Right, next one. The diagram shows positions of yacht Y and ship S and a beacon. The bearing of B from Y is 228. Find the bearing of Y from B. Now, what did I say about the from? Where we see from Y, what do we draw?
North.
We draw our north line. So they've already done that for us. They said the bearing of B from Y is 228. So what that means is that this there is 228. So the blue part is 228.
Oh.
Now, we're probably going to be doing something else in a second, but let's just leave that for now, because that's the only information they've told us. They've asked us to find the bearing of Y from B. Okay, so that means that we need to find the bearing to get from B to Y. So what do? We sketch a north line at B. It's a little sketch.
Oh, yeah.
Yeah, you will have learnt this at some point. It's a small topic that most people forget.
Does anyone remember?
No.
It could have been in year 9 or 10.
Yeah, I don't. Has anyone seen it in their life?
It's not whole, everyone. I'm going through it with you now.
It's 135. Well,
So,
that's what I got.
Now, hang on. When I was talking about the protractors, it doesn't. Oh, you were doing some calculations. Okay.
Well, it's 132, but I said it was 135 based on my protractor.
No. Okay.
Oh my god.
Too many conversations going on. So if they want the bearing of y from b, what they want to know is this angle here.
Okay.
Do you all see that? This is our north line. This is the line joining b and y. And they want to, it's always measured in a clockwise direction, so they need to know this missing angle.
45. Okay.
So what we need to do is, the important thing here is it says this. The diagram is not drawn accurately, nor does the board draw accurately. So, pardon? Yes. Am
Yeah, you are.
Yeah. I am. So, what do you think can help us find this black angle? Looking at this diagram, let's have lots of hands up. Everyone should be looking at this, telling me what they think they can establish from this. When I said lots of hands up, it wasn't just for the sake of it, I think it was actually have a response. Elena.
Would you be able to find the angle where it says y and then find
Do you need this one?
Yeah.
Yes, you totally can. How can you work out that green one? Perfect. Does anyone know what that is?
132.
132? Now, how's that going to help us find the black one?
So you could probably do angles on a straight line.
Now, you've got to be careful with angles on a straight line. Remember, angles on a straight line are where you have a line, and it's where those angles meet, like the little baby protractor do.
Yeah.
But you would get the right answer, even though it was the wrong reason. Jamie?
Is it the interior angle?
Yes, but these are actually, it's co-interior angles. Do you remember that?
Mm.
Co-interior angles are where we have parallel lines, and then we have a line joining them. Now, you may say, but what are parallel? Well, if this is the north line and this is the north line, it must mean that these two lines here are parallel to each other, yes?
So like this.
So that means that this angle and this angle have to add up to 180 because they're co-interior angles. So it tends to be a situation where they will often use angle geometry to get you to work these out if they are not requiring you to draw the angle itself. So that means that the black angle would be how much?
48.
48. So if they've asked for the bearing of y from b, what would you write? 048. Because what did I just say about has to be 3 digits? Yeah? Cinchi?
Yeah.
The bearing of S from Y is 118. So S we're talking about now.
We have to put the 0.
Yes, otherwise you will get it wrong. I'm erasing all of that bad boy. So the bearing of S from Y is 118. So that means that this angle here is 118. Find the size of angle BYS. BYS. Oh darn it, I got rid of stuff. What was this baby here?
132.
Thanks. And so, if they want to know angle BYS, we're looking for this baby here. And no prizes, because I think that's a pretty straightforward one. We know that these angles add up to 360, so you can find what's missing. I'm moving on. Oh, here we go. Given also that by equals sy, find the bearing of s from b. Of s from b. So from b means we draw a north line here. If they've told us that these two lines are equal to each other, it means that we've just formed here what kind of triangle?
I saw
An isosceles, yes? And, or what was this number?
220. Wait, 228 was the whole thing.
Alright, so what's this baby here? 110? So that was 110. What does it mean that these two angles down here would be?
Oh, I know. You do 180 minus 45 and then divide that.
Yeah, so 180 minus 110 is, come on. No, 180
70,
minus
so it's 35.
35.
It's 35.
70, and what's half of 70? Okay, so, but that's not the full bearing, is it? Because it has to be measured from north. But we know that this bit here, we worked that out to be 48, didn't we?
Yeah.
Remember from here? I know, but I'm trying to get as much help done as possible. Sorry. So then the bearing would be 48 plus 35. Which is 83. So our bearing would be 083.
What is this?
Right, so they told us that By was equal to Ys, so that means that that blue would be an isosceles triangle. We worked this angle out here to be 110.
Oh, so you know at the bottom.
So it means that these two have to be equal because they're the base angles. So you do 180 minus 110 divided by 2.
Yeah.
But they want the bearing of S from B. So that's this whole angle here.
From
S
of S from
of S from B. So it's the B has to have the north line, and then you're measuring that angle. So you'll only need a north line at the position where it's from. So if you were measuring something from S, then you would sketch a little north line at S.
I thought you were better. What? Okay.
I'm sorry, Mia?
Are we doing all the variables?
No. I think I thought I'd just go this one next.
Why did you attack initially?
Because we're talking about B, like B and S would be connected. S and B. I'm sorry? They told you that these two lines are equal in length. Here. Yeah? Right, okay, next. So this one here, what topic is this? Pardon? Upper and lower bounds. Do we all remember that?
Oh, yeah, subtract 5 and add 5.
Yes. So it says, correct to the nearest millimetre, the length of the side of rectangular hexagon is 3.6 centimetres. Now, they've said to correct to the nearest millimetre. So you need to recognise that a millimetre means one extra level of accuracy. Yes? Does that make sense? So they've said 3.6 centimetres. So this, the 0.1 is the level of accuracy. So it says calculate the upper bound for the perimeter of a regular hexagon. Well, what do we know about hexagons? How many sides do they have?
6.
Alright, so they tested that there. So we know that a hexagon has 6 sides. If you didn't know that, you're in doo-doo really. So you might get something for some kind of working. So if you're thinking about an upper bound for the perimeter, when we're finding perimeter things, what are we doing to our measurement?
Adding all the sides.
Adding the sides together. So if you're trying to find the upper bound, it means you just need to find the upper bound length. You don't have to worry about the lower bound. If you recall, sometimes when we're doing application questions here, you have to sometimes think, okay, how am I going to get the biggest value or the smallest value? And it's not always necessarily to use the upper bound or the lower bound. Sometimes it's a combination of things. Do you remember we did some questions like that?
Probably.
What's the highest for this and you like
Yeah, so like if you had A over B, if you want the biggest number possible, then you would have the maximum value for the A and the minimum value for the B. That would give you the biggest number. Do you remember all that stuff?
I remember learning it. I don't remember
You
it.
won't remember because you did it last year.
Yeah, I have to learn a little.
You will, because you were here. I was pointing in Casey.
No, I got a feeling.
Well, I said no. When I said you will, you should. Right, okay, so remember for upper and low bounds, we pretend the decimal is not there. We add a 0 to it. Okay, so that is our number currently. For our upper bound, we add 5. For our lower bound, we would subtract 5. So this becomes 365 and 355. And then we put our decimal point back into where it should be. So that becomes 3.55 and 3.65.
But if it was 3.65, wouldn't you round up to 3.7?
So no, so remember it's the bound, it's the boundary. So officially when we're doing upper and low bounds, the 5, you take as the maximum value.
Oh my gosh, I have to do this now. So,
Okay? So if we've got a perimeter of a regular hexagon, we would then do 6 multiplied by 3.65, and that answer goes in there. Okay? Correct to one significant figure, the area of a rectangle is 80 centimeters squared. Correct to two significant figures, the length of the rectangle is 12. Calculate the upper bound for the perimeter of the regular hexagon. What?
Or so you divide
Oh, for nothing. No.
Oh my god.
It's not really making any sense that
nothing about this sense.
no, I believe there's some typo going on here.
We didn't understand. No, I shouldn't.
Well, to one significant figure, someone you like add.
I think no, but they've suddenly just talk about rectangles and suddenly they bring in hexagons.
Oh, because there are rectangles and hexagons.
No, I think both of you're being very kind, but I think the exam bank program has just got a bit haywire for this bad boy, so let's just skip that.
No, let's just pretend it's rectangle.
Can we just cross it out?
Because, like, this seems like
No, can we not do this?
What if we don't?
what if they form a wall and it's something we should know? Yeah, can we
Alright, so okay, if you
Wait, so is it not just rectangle?
okay, so let's pretend it's oh my gosh, let's pretend it's a rectangle then. Shush!
But what if we don't know?
Listen! It's not going to talk about rectangles and then talk about hexagon. It's just a typo.
Oh!
Oh!
Yeah, we couldn't see that from back here. I thought it was all the same. So sorry. I was reading it out there. Okay. Gotcha now.
So, wait, do you want us to do it so we're pretending this says rectangle?
Yeah. Yes.
Alright, so, shh. Oh my gosh, girls, seriously.
What was the thing? Sorry, please continue.
So it says the area of the rectangle is 80, the length is 12. So what other information do we need in order to find the perimeter of something? We need to know
The width.
width of it. How can we find the width if we know what the area and the length are? So really?
We could use the area divided by the length.
Yeah, so we do 80 divided by 12. What's 80 divided by 12?
6.6.
6.6 we can.
Yeah.
That's very nice. I'm not quite sure that this is...
Now we get.
Don't we just do, we add 12 plus 12 and then subtract between 80 divided by 2.
No. Pardon?
We do 12 plus 12 is 24 minus 80 and then divide that by 2. Get rid of it. What is the rectangle?
I think
No, it's about the area of a rectangle you would multiply.
Oh.
Scrap this, we need to find the upper bounds first. So, the upper bound of the area would be what? Remember I said you pretend
85 and
this is
70.
80, so we would say that it would be 85 and 75. So our upper bound is 85, yes?
Yeah. So the lower bound would be.
So, to get the upper bound of the width, we would take the lower bound of the length.
11.5.
Are you with that?
Yeah.
So you just one more time?
So to get the upper bound for the width, we would take the lower bound of the length.
Why? Because to get the bigger number, you have to do the big one divided by the small one.
Because if you divide by a big number, it's going to be. But why are we trying to divide by? Okay, wait.
Because we're
Sorry.
talking about the big
So
numbers.
to find the area, we need to have base times height. But we have the base, but we need the.
So we need perimeters. So we do need the width. Lily, do you understand?
No, but I can figure it out myself.
Oh, well, no, I would rather assist you if that is going to make life easier. So if two numbers have been multiplied together, okay, and if I want to know the maximum output, I would just take the maximum value for A and the maximum value for B, and that's going to give me the biggest number possible.
Yeah.
That's a bit obvious. Well, I hope, yes?
Yeah.
But when it comes to dividing, if I was doing A divided by B, to get the biggest output here, I would need to know the maximum value for A and the minimum value for B. Yes?
I didn't understand the initial question.
Roger that.
So I like that. I understand.
Okay.
But why are we finding that?
Casey, are you with that?
A little bit.
I've got that really practice to that voice.
Yeah.
Right, okay, so we've got our maximum value for the area, and what's our minimum value for the length?
12.5.
So it was 12,
So it's 11.5.
so remember we say 12 and we add a 0, and so this would be 125 and 150, and put our decimal back in, and our minimum value here is 11.5, yes?
Then it's 85.
So we have our width, we're going to have 85 divided by 11.5,
7.39.
7.39, exactly.
No, but there was like the next number was a 1.
What if it's multiplied?
No, you multiply it by 2.
Well, yeah.
I know, but can we have a few more?
Oh, it's like 6. Sorry, it's 7.39130434.
Okay, that'll do.
Yeah.
So if that's our width, then we're going to have 2 of these, and they want the upper bound. 2 of these, yes, and add those all together. So 2 of these, 2 widths, and 2 of the upper bounds of the length.
Should we correct it to 360? Or it's like upper lower bounds, should we like round it up?
All right, okay. I've got lots of people shouting out stuff. I'm trying to address them all at but too many things going in my head. Sure. Yes. Round to 360.
It's 39.2.
Thanks.
Wait, what did it just be? 38.8? If it's
I don't know.
if it's
I haven't
39,
added
if it's
these things up.
38.7826.
You got 38.78?
Yeah.
Right.
Why? Okay. That's
So
Because it's
girls,
4 times.
some people were saying, I'm going to have no clue what's going on. Well, I need you to have a clue what's going on. To find the perimeter of a rectangle, we have 2 lots of lengths, 2 lots of W, and we add these numbers together, yes? That's how we find the perimeter of a rectangle. If I want to know the upper bound of that perimeter, I need to know the upper bound length
No, it's 2 times the upper bound.
and the upper bound of the width. Now, the upper bound of the length, we've just established is this, 12.5. We haven't used that value yet, we've established that's what it was. We were just able to find the upper bound width by doing the maximum value for the area and the minimum value for the length. And that must be therefore the upper bound for the width. So we're going to have 2 lengths of the 7.39 blah, blah, 2 lengths of the 12.5 and add those together. Is everyone clear on that now?
Yes.
Now, you're not going to have this exact question ever again. But it's the concept that I want you to be thinking about. So don't necessarily, when you see upper bound, think, oh, I need to find my 2 upper bound lengths and add those together. Because that's not always going to be the case. Okay? Next one. Why did I choose this one in particular?
I don't know.
Oh!
A watch.
Alright, so the sides of the triangle PQR are tangents. And the tangents touch the circle at the point STU.
There's another question on that page.
Oh yes, I was just picking and choosing things, so I was going through some of them and then leaving you guys to have a practice with the others. So that's summarising that. Write down the length of QT. Alright, so this is going back to angle geometry. Looking at length QT, who can tell me? Shayla, I'm picking on you. Wait, what's the length of QT? What do you think it might be? Have a look at the diagram. It's not drawn to scale, but have a look at it. What do you think it
I
is?
don't know how I know. So,
Right, they told you that these lengths here are all tangents. Okay? Now, if they originate from this point here, and we've got a tangent here and a tangent here, what's special about the lengths of the lines up to where they touch the circle edge? They're equal. So what does that mean that length QT would be?
Oh my god.
What I need for you guys to do is to guess where possible. Okay? So now in an exam, just be honest with me, Shayla, would you have left that blank or would you have chucked a number in? You would have skipped. Okay.
or I would come back.
Alright, but I would like for more of you to be looking at that thinking, well, these numbers are here for some reason. Like, this goes from here to here. I need you to think, oh, well, maybe it's the same length as this.
What would our reason be?
So the reason is because the tangents from an external point hit are equal.
Is that like a short way to put that?
Tangent. Oh. No, not really.
Tangents from external points.
Hit the circumference,
Tangents are equal.
and then the tangents are equal. Yeah.
Tangents external are equal.
Yeah, sure. That's a good one.
The perimeter of the
Right, so the perimeter of the triangle PQR is 42. Calculate the size of angle PQR. So they want us to find this angle here. So they've said that the perimeter is 42. So, what does that, what am I trying to say? We've established that this length here is 6, yes? Is there anything else that we could label? Jamie?
It's CR7. No, is it not?
No.
This one is 7.
The one, yeah.
Okay, a few more people looking in?
Oh, would the UR be?
So, not you, no. So we have to fill in information that we know for sure, not what it looks like, what we know for sure.
Okay.
So we know that from this point, these two lines must be equal to each other, which means that if that rule applies, then this, if this is 7, then this also here must be 7, yes? Now, I'm not asking what the value is, but what does it also mean about these two lines? They're equal, yes? Are you with me so far? Well, they've told us that the perimeter of this is 42. So we've got a 6, a 6, a 7, and a 7, and then 2 equal lengths. Yes? So I know that 6 plus 6 plus 7 plus 7 plus x plus x gives me a length of 42. So that's 12 and 14 is 26. So it's 26 plus 2x is 42. So 2x would be 26. X would be 13. So as you can see, like that doesn't look like it from the diagram, but it's not drawn to scale. And and you have to use geometrical reasoning in order to be able to set up equations and things that you know for sure, not what you think it looks like.
Why could you not just do 42 subtract 6 plus 6 plus 7 plus 7?
Well, essentially that's what I did here.
But then I got, would it not
I
be
didn't get
16?
that.
Yeah, I got 6.
Is it not 26 and
Yeah.
16? Oh,
Yeah, I
look
was
at
I
them.
was
I got
That's
that.
true.
I thought it was going for 6, so.
Bless my heart.
Okay, so it'd be 8. Gotcha.
Okay, good.
Alright, I'm not going crazy.
Oh wait, is that better now? We've got the right answer.
Yeah.
But that's not the question. Well, we're getting
We're not done.
Oh yes. I forgot we actually had to answer a question. So we know that this length here is 8. So we have got,
Oh,
well, we've got a few choices, but we know this is 8 as well. So what shape is this, did we say?
isosceles.
And what rule do we know about triangles?
Okay.
And what else if we want to know angles?
They all
Same cos tan.
The sine, cos, tan, not secretly tan. What was the first thing we were looking at? The cosine and sine rule, yes? Back to that. So we're trying to find, so if I just drew a sketch of that, here's my angle I'm trying to find. I know that this length is, what was it? 13. This is 14, and this is 15, I think. So here we've got 3 side lengths and an angle. So which rule are we going to use? Cosine. So we know that cos theta. Oh, now to get the rearrangement, I don't think you do you? Right. This is where you have to remember how to rearrange it. Does anyone remember the rearrangement?
I looked at it yesterday, but I didn't.
Right. I'm going to try and help you by if you look at the cosine rule, everyone looking at the cosine rule.
Wait, can I say what I think it is?
Okay.
Oh wait, it's the cosine rule.
Oh, mamma mia.
A squared equals B squared plus C squared.
Yeah, I don't know. Mia, am I right?
No, a squared minus b. Yeah. Yeah, you don't need
She just wants to rearrange. She's gonna tell us.
All right, I'm trying to help you by looking at this to work out what the rearrangement is. So if you see that you've got length A, baby length A, and then talking about big angle A at the end, yes?
Yeah.
So what we would do is switch those two. So the 2bc cos A goes on the left, and the A squared is going to go on the right. Are you understanding what I'm saying?
Yeah.
So this is what you have. A squared equals B squared plus C squared minus 2bc cos A. So because this is a takeaway, I'm going to switch these two. So I'm going to now have 2bc cos A equals B squared plus C squared minus A squared. And then cos A is B squared plus C squared minus A squared over 2bc.
Okay.
Okay? So, I always remember it is that the angle I'm trying to find is that's the length that's being subtracted. And then these two letters on the bottom are the same as the first two ones.
Yeah. Okay.
Okay? So then we're just going to stick those values in. So you've established that these are your B and C. Doesn't matter which one's which. This is your A. Chuck it in, and don't forget to do the cos to the minus 1 bit. Because you actually need to find the angle, not cos of the angle.
Wait, what?
89.9. When you want to take the cos away, you have to do cos.
Because that enables you to find cos of theta. But you need to know theta, so you have to do the inverse cos. Remember the button above that shifts cos or whatever they are?
Can you work up the answer someone so that we're not freaking out?
Oh, we're at